Hello guys, welcome back once again in RoboJunk YouTube channel. Today in this video I'm going to cover about 555 timer IC. I will be covering what is 555 timer IC, how does it work, and what are the application of this IC. So let's start the video. So as you can see here, 555 timer IC designed by Hans Kaminsin in 1971, and this can be found in many electronic devices starting from toys and kitchen appliances. Even we have like washing machine, right, that also has this kind of timer IC. It is highly stable integrated circuit that can produce accurate time and oscillation. So the most important thing is this IC is capable of producing accurate time delays. We can generate a delay in microsecond, from microsecond actually till hours. From microsecond to the hours we can generate the delay with using this IC. So that is why, because this produce accurate time delay, that's why we say 555 timer. And also we say 555 timer IC is used for time based applications. One example, let's say traffic light. In traffic light you would have seen there are 3 lights, right? So between each light there will be time delay, so that time delay adjustment can be done using this IC. Even if I give you the example of washing machine, in the washing machine basically we have a timer, like we can set 30-minute timer in washing machine, and once the time basically ends, let's say 30-minute timer we have set using this 555 IC. After once this timer ends, then you would have hear a sound, right, buzzing sound, a music, right, music will start playing. So that is another application in our basically home itself, like washing machine. Yeah, so the 555 timer has 3 operating modes: bistable, monostable, and astable mode. So we will be discussing about each mode today in this video. I will request please watch this full video to understand everything related to this IC. Yeah, so as I said, like this IC is used in toy, alarm, oscillation, timer, and industrial electronics also. Right, this has basically this has very vast applications. Yeah. Now pin, coming to pin, how many pins are there? So total 8 pins are there. Let me just show you here. Yeah, this is how the IC looks. It's available in a DIP package, DIP. It comes in a DIP package, dual inline package. And then these are the pin number. Pin number 1 is ground. In every IC one thing is common. In every IC you will find this notch. This notch will be there in every IC, and from the notch the left one is basically pin number 1, 2, 3, 4. So numbering will be always in U shape. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Every pin has basically functionality. I will explain about each pin: trigger, what is trigger, what is output, what is reset, control voltage. We will discuss about each thing. Yeah, you can see again here, this is the pin out basically of this IC. Now these are the application, like we can build LED flasher, we can control the motor speed using 555 IC, we can generate a tone like police siren sound, we can also use like IR, remote timer, electronic dice, delay of light. So basically we can build actually more than 100 number of projects using this IC. Okay, now what is IC? So IC basically stands by integrated circuit. Inside 555 IC you can see these are the components. These many components are there inside a small silicon chip. Yeah, so basically ICs are made by silicon, and inside 555 IC there are 25 transistor, around 10 resistor, and 2 diodes. This is the internal structure of a 555 IC. Okay, but all these things are compact in a small silicon chip. That's why we say IC. So whenever you hear this term IC, you have to understand one thing, guys: there are multiple components which are embedded into a small chip, right? Okay, we'll move forward. Yeah, now this is the block diagram of the 555 timer IC. So basically it's called 555. One of the reason is basically there are 3 5 kilo ohm resistor connected in series, which creates a potential divider. So I will explain what is this potential divider. Yeah, there is a transistor here. This is a discharge transistor, and then there are two comparator. These comparator will compare the value, and depending on the comparison it will give the output. This is the output pin. Here you will be getting output either 1 or 0. So there are two comparator, and there is a flip-flop. Flip-flop is a device which can basically, it's a component basically. It's a component which can store 1 bit of data. So either it will store 1 or 0. 1 bit of data it is capable of storing. Moving forward, now this is the most important thing. Now I'm going to explain how does 555 timer IC works. Okay, so just listen all these things carefully. Yeah, so as we understood, there are 8 pins in the 555 IC now, and there are 3 5 kilo ohm resistor, right? 555, you can see all these 5 kilo ohm are connected in series, and they are connected in a manner it's creating reference point, two reference point, and this circuit is called potential divider. For better explanation, I will break down here. I'll take 3 resistor, 1 2 and then 3 resistor. Okay, so you can see one point is here, so I'll take one point here, one more point is here, I'll take another point here. There are 2 points which I've taken. Okay, now let's say all 3 are same values, so I'll take R. There are 3 R. Okay, what will be the value here? So potential divider formula, if you don't know, let me just show you. V output, VO equal to V in input voltage, basically output voltage equal to input voltage R2 and plus divided by R1 plus R2. So in this case all 3 resistors have the same value R. So according to this formula, this is a potential divider or voltage divider formula. So we are calculating what is the voltage here, what is the output voltage here. So V out. Okay, now I'll write here. So V out equal to V in into R2 divided by R1 plus R2. This is the formula. Okay, now in my case all the values are same, right? So here if you see here, this is all, there are 2 resistors here downside. So according to V input, I am assuming VCC. V input is VCC. It can be anything, so we can provide input voltage from 5 volt to 15 volt. Okay, we can power this IC from this range. This is a voltage rating, basically 5 volt to 15 volt you can apply to 555 timer IC. VCC into R2. So there are 2 resistor downside, if you see, R and R. So instead of R2, basically R2 has basically 3 things, R2 and R3, and both are same value, so 2R, and divide by total resistance. Total resistance are, how many total resistance are there? 3R. 2R by 3R. So you will be getting VCC 2 by 3 VCC, basically you will be getting 2 by 3 VCC. That's why you can see here 2 by 3 VCC is here. Okay, now if I calculate here at this point, again according to voltage divider VCC, let me write here, according to voltage divider formula, VCC equal to V output equal to VCC into R, just R, because you can see here just one R is there this side, right? We are calculating at this point, R divided by total R, means we will get 1 by 3, R will be cancelled out, and then we will get 1 by 3 VCC. So these 2 points are there, 2 by 3 VCC and 1 by 3 VCC. According to potential divider we can calculate, here we are getting 2 by 3, here we are getting 1 by 3. Now what is the use of this thing? So these things these two reference points are connected to comparator, and one of the comparator is connected to threshold pin. Positive of comparator is connected to threshold pin, and the other comparator negative pin is connected to trigger. So positive we say basically non-inverting point, and negative we say inverting point in electronics. Okay, and these two are comparator. So whenever threshold, on the threshold pin, the voltage will be more than 2 by 3 VCC. Whenever the threshold voltage will be more than 2 by 3 VCC, okay, then it will make the value 1. It will make the output 1. Okay, and whenever trigger value on the trigger pin, whenever the voltage goes below 1 by 3 VCC, then it makes the output 1. Okay, in reverse case, if trigger voltage is greater than 1 by 3 VCC, then it will make 0 output. Here also, if threshold voltage is lesser than 2 by 3 VCC, the output will be 0. Okay, and then these output will be fed to flip-flop. Now flip-flop, basically, let's say, let me just erase this one. Yeah, now let's say here we are getting 1 and here 0. This side will become 0 and this side Q bar will become 1. Okay, that's how flip-flop works. Okay, so if reset is 1, it will basically make Q bar 0, and set is 0, then Q bar will be 1. Okay, now this 1 will be 1 means basically 1 at this point will turn on this transistor. Now this transistor is used, this is called discharge transistor. So here there will be capacitor connected in the circuit. There will be capacitor will be connected to this pin. So when this transistor will on, capacitor will start discharging the capacitor. Okay, whenever transistor will get 1 at this point at Q bar, the transistor will turn on. This is NPN transistor, and it will start discharging the capacitor connected to pin number 7. Okay, now because 1 is here, the inverter, there is an inverter, so whatever value will be here, it will be inverted. If 1 is here, then it will become 0. Now let's take another. Now we will assume 0 at this point, 1 at this point. Okay, so we will get 0 here, 1 here. So when 0 is at this Q bar, the transistor will be off and capacitor will start charging. Okay, so due to capacitor, because capacitor takes time to charge and discharge, that's how we can generate the exact delay whatever we want. If you attach higher value of capacitor, it will take time to charge and discharge, and whatever you have connected to output pin, there is an output pin, this one, whatever you have connected to output, that will turn on. Let's say in case of LED, if you have connected a capacitor, if it is charging, the LED will remain on. When it is discharging, slowly it will turn off. So those things, so that's how the delay generation works, right? Okay, so if 0 is here, the transistor will be off and capacitor will start charging. Okay, and it will invert the value, so you will be getting 1 at this point, and whatever you have connected at output, whether it is LED, speaker, motor, it starts working. Okay, so there are two important pins, threshold and trigger, because these two pins are going to decide what will be the output on the comparator, right? And the comparator output, as they're going to feed in flip-flop, and then flip-flop will make the output either high or low, either it will make 1 or 0, right? There is one more pin, reset, over here, pin number 4. The reset job is, let's say flip-flop has 1 stored in this, right? You can have a reset pin connected to GND. Whenever you can have a button, let's say there is a button connected to GND. So whenever you basically press this, you can reset the value, again it will be reset. Okay, so that's what basically the use of this reset pin. Coming to control pin is connected to minus of this comparator, so you can control the voltage from here. you can have potentiometer, you can have some capacitor, some combination you can create on pin number 5 to control basically this negative of the comparator, right? And threshold is basically setting the limit. Two important pin, VCC and pin number 1. Pin number 1 and VCC. VCC is basically input voltage, and the input voltage can be in range of 5 volt to 15 volt, because that's what you can apply to 555 timer IC. And pin number 1 is GND. So these are called power pin also, because these plus and minus is needed for any electronic component to work, right? Yeah. So this is how it works. If you have any doubt in this working things, whatever I have explained, you can drop your comment. I would be happy to answer your questions. Yeah. So now you can see here, this is how the latch work. SR latch, we say latch. 1 0 means if S is 1, R is 0, the output will be high. That's what I showed you. If S is 1 and this is 0, because Q bar will be 0 and then inverter will make it 1. Okay, so if S is 1, then you are getting high output. If S is 0, you are getting low output. Okay, 0 0 is hold previous and 1 1 is invalid. Okay, now voltage divider 3-5K resistor creates reference voltage 1/3, 2/3 already I have explained. Comparator triggers and threshold voltage. Okay, flip-flop stores state, set or reset. Discharge transistor control the capacitor discharge, as I told. Output state drive load up to 200 milliampere. This is very important, students. We can also control the motor with this, because motor needs generally 100 milliampere, 150 milliampere. So you can easily drive a motor with this 555 timer IC. That's why we use PWM for controlling the speed of the motor, right? We can connect LED, relay, motors, all those things. 555 timer IC works by using two internal comparator. Already these things I have explained. Going forward, yeah. Now there are three modes, so we will talk about the modes. First mode is Astable mode. Astable, I'll give an example, like let's assume LED blinking, right? When LED blinks, we can change the time delay, right? We can turn on the LED for 2 minutes. Not 2 minutes will be very much. We can turn on the LED for 2 seconds. Then again for another 2 seconds we can turn it off. So that time adjustment, basically we can do that. So Astable mode is basically you don't have any stable mode. Once you power the IC, once you have connected all the things according to Astable, then it will just make the LED blink on off on off on off. This kind of signal keeps on generating, right? They keep on generating. Okay, there is no basically stable state. That's why we call Astable. Stable state means there is no like LED will just keep. LED will be in on state all the time until you press any button. Not like that. Astable means once you power the circuit, then LED will keep on blinking like that. Okay, I will also show one of the circuit diagram. These are some formulas basically to calculate the on time, for how much time the LED will be on, how much time, whatever basically if you have connected motor, how much time motor will be on. Okay, so this is how basically you can calculate 0.693 R1 plus R2. These are some formula. These are the resistor value. Here you have to feed the resistor value and then capacitor value. So capacitor and resistor value will be helpful to basically calculate the on time of the circuit. Yeah, total period on plus off time. Okay, then frequency. For frequency, this is the formula for calculating duty cycle on off time percentage, right? So duty cycle is basically on and off time percentage. So that also we can calculate with this formula. So yeah, now a stable circuit. If you see this circuit diagram, this is how you have to do the configuration. You have to do the connections to basically to get the stable multi-vibrator circuit. Okay, you can see 2 and 6 is connected, threshold trigger is connected, and then 2 is connected to this R2, and then it's going to 7. So this is how basically multi-vibrator circuit looks like. Monostable. Monostable is basically, for an example, let's say you are building clap switch. When you clap, the LED turns on but after some time, after some delay, LED turns off automatically. Okay, I clap, LED is on now, and after some time automatically LED is turning off. So there is one state, it's required one trigger point. Whenever I am clapping, it's waiting for the clap, it's triggering the LED is turning on, and after some time LED is turning off. There is no control on the off state. That's why just one state is common. On the one state you have the control, which is clapped, and after that you don't have control on the off time, right? It will turn off automatically. That's why it's called mono. Mono means one. Okay, for monostable, these are the formula. Pulse width we can calculate with this. We can calculate the frequency, duty cycle. These are the formula. Okay, now monostable circuit is this one. Clap switch. There is a mic. When you clap, it will go to transistor. Transistor will amplify and it will go to trigger. Okay, so you are giving trigger using the mic, but automatically this LED will turn off. Automatically it will turn off after some time, after basically 5 minutes, 2 minutes, 1 minute. That depends on what kind of capacitor you have used. If you have used 100 microfarad, it will be on for a long time. If you have used 1000 microfarad, it will be more longer, right? So time we can basically increase and decrease by changing the capacitor value. Coming to bistable mode. Bistable mode is basically two state. You can see here you have control on state and off state. For example, let's say you have connected two switch in the circuit. When you press one of the switch, the LED will be on until you are pressing the second switch until you are pressing the second switch. The formulas are basically set condition, trigger is less than 13 VCC, reset is less than. So these are some conditions. Yeah, you can see here, coming back to diagram directly. This one is connected to pin number 2. That means one of the button is used to give trigger to the LED. So when you press this first S1 button, the LED will be on. Okay. When you press the second one, because second one, if you see, it's connected to reset pin. Second one is connected to reset pin. So when you press the second one, what happens? The LED will turn off. Okay, so let me explain you the circuit of bistable. I'll make this circuit diagram on Tinkercad. Okay, I will take all these components. I need one 10 kilo ohm, actually two 10 kilo ohm resistor, one 555, one 220, one LED and two button, and I need this ceramic capacitor 0.01 microfarad and battery. So let's take all the components in Tinkercad. So this is there, 9 volt battery. I'll connect, and then 555 IC. I'll take 555 IC. I'll take two 10 kilo ohm resistor. First LED also I'll take LED. Resistor 1, resistor 2, resistor 3. Okay, value 10 kilo ohm, 10 kilo ohm, and this one 220. 220 ohm. 3 resistors I have taken, and then I need ceramic capacitor, and the value is 0. What is the value of this? So you can see 0.001 microfarad. Basically I'll take, where is that one? Yeah, let's take 10 nanofarad. Okay, so that's what basically we need, and we need two buttons, one trigger button and one is reset button. Let's start building circuit. I'll explain step by step. So first let me delete this thing. Yes, now we'll start from pin number 1. Pin number 1 is connected to minus of the battery. This is minus, this is plus of the battery. Okay, pin number 1 is minus. Let's do that. 1 is negative. Pin number 1 is notch is here. Pin number 1 is negative. Pin number 2, what is connected to 2? So if you see, pin number 2 is connected with a button, one of the button leg. Okay, let's do that. One of the button leg is connected to pin number 2, and the other leg of same button is connected to minus of the battery. This is minus. So other leg of button is connected to minus of the battery. Next, coming back to this, one more thing is connected to pin number 2, 10 kilo ohm. 10 kilo ohm is going to positive. Okay, so let's do that. 10 kilo ohm, I'll take one, and it's connected to 2 to positive. So I have connected here. Done. Coming back to pin number 3. 3 is connected with 220 ohm resistor and going to plus of the LED. This is plus of the LED. Let's go back. Plus of the LED is here. 3 with a resistor it is connected. So the resistor is 220 ohm. I'll take this 3. To plus of the LED. Minus of the LED, you can see it's connected to minus. Okay, so minus of LED is connected to minus. This is done. Next, pin number 4. 4 is connected to positive with 10 kilo ohm. So let's do that. 10 kilo ohm, 4 to positive. Done. Okay, next. Also there is a button on 4. Okay, so let's connect one of the button leg to 4, this button. So 4 is connected to this button leg, and the other button leg is going to this button leg is going to this button leg is going to minus. Let's do that. Okay, so this is connected to minus. This is done. Next, pin number 5, control voltage connected with ceramic capacitor 0.1 UF. So I'll take 10 microfarad. Okay, 5, yeah, and then another leg of this is going to minus. So let's do that. Another leg of this is going to minus. So I'll connect like this. Yeah. Next, pin number 7 is left out. Pin number 8 is connected to positive. So let's do that. 8 is here. 8 is connected to positive of breadboard. Yeah. Let's change the color. Now anything else? All the connections are done. 6. Threshold is connected to minus of the battery. 6 number pin is connected to minus of the battery. So I'll connect that. I'll change the color again. Now kind of we have done. So let's do it. Okay. You can see when I'm clicking on the trigger, second pin is trigger. You can see here when I'm clicking on trigger, LED is on. If I'm clicking on the reset one, LED is turning off. If I click on trigger button, LED is on. It remains in on state until you are pressing this one. Okay, so that's how basically 555 timer works in 3 different modes. I showed the diagram of bistable mode. Guys, you can search for astable mode circuits like LED flasher is astable mode, clap switch is monostable mode. So you can just search for circuits on different modes. You can find n number of circuits on the Google and you can build that. Yeah, so that's how basically 555 timer has a vast application, and we use 555 timer in daily to daily life, also in lot of machines, lot of appliances which we have in our home also. So if you like this video, please hit the like button and do subscribe RoboJunk YouTube channel. Thank you.